Let's begin. I'd like to thank you for giving me the chance at this symposium to talk my test experience for BMS. In fact, this is my first to give English speech on stage. I'm very nervous and grateful to my friends. They helped me a lot. Now let's begin. This is agenda. First of all, let me introduce my work. We mainly produce BMS products for new energy vehicles, including passenger cars and commercial vehicles. Until 2018, we produce their product output is 200,000 cells and 150,000 cells in their respective fields. And the safe use is over 5 billion kilometers and 6 billion kilometers. We design and produce, centralize and distribute BMS according to different customers. We cooperate with many international OEM, such as FCA, Daimler. At home, we have established a strategic cooperation with most of the multi-bell, such as Geely, Guangqi, multi-bell. In the way model, our verification work mainly include software testing, system integration testing, system testing, unit testing, and vehicle testing. And VT, Visual Studio, Virtual Target are our main developed tool chains. Of course, unit test and vehicle test is not our topic, though we use vector cost in our unit test level. Several challenges were encountered in our test development. The following are two examples of them. One, multiple software projects foster interactive test and delivery. There are so many customers to deliver BMS to, and what's even worse is that the development cycle is becoming shorter and shorter. With the increasing number of projects and increasing number of test cases, at the same time, we have encountered some hardware limitation. For example, there are always delays in making hardware samples with the plan changing of OEM. Or there are something wrong with the hardware sampling. Especially some software test level count accurate measured in the real hardware. That will block BMS verification. Because originally the verification of BMS function is run in hardware environment, which leads to inefficiency in development and unacceptable automatic running time. The important is the errors found in software test level account for more than 19% of the BMS errors, but we verify it in the real hardware, real environment. I think that makes no sense. For challenge 2, multiple sub-projects left circle management, especially requirements and test case. More and more projects and more human resources needed to development automation test case for various projects. Also, needed to develop system requirements, system architecture, system software architecture, software requirements, and so on. They need to be traced with each other for consistency and for software quality. For the first challenge, we built a virtual test system based on virtual target, which can quickly develop and run software test case without relying on real environment. This greatly improves the test efficiency. In our test framework, all test cases are environment independent and can be seamlessly switched between virtual and real environment. Based on our test framework, the software verification and system verification test case can be implemented on early stage, especially the software test. You know, the software test script is also software development, spending lots of effort for debugging. Because the same test environment, the system test script can be debugged earlier. After debugging pass, it can be direct run in real environment. With this test plan, the most Hill device and hardware simple may be spared. But the precondition must clearly defined in the test plan. In our test plan, our test principle is that the scope of software test level is logic function, software strategy, software architecture. The real fault injection system function-based hardware sampling, running time, stress, and robot needs are within system test level. Of course, all software test case and system test case will be run in real environment on latest stage. How to ensure all the software test case and the system test case can be run both in virtual environment and real environment is that abstract the interface interface variable and emulate the hardware function and peripheral electrical architecture. Also a step in the virtual test environment. Let's take the HVL for example. HVL means high voltage in the loop. Oh, sorry. The red line is high voltage. The green line is delector. When the collector is open, the green line will detect it, and the BMS will report an error. So when we in the real test environment, when we call the interface TE HVL open, VT will satisfy the open for junction like that. But in virtual task environment, we will send the special level to the haze ledger of virtual task interface. It depends on the hardware circuit. For the second challenge, we built a complete multi-project framework, which automatically generates the customer's project's system requirements, software requirements, system architecture, software architecture, code, test case from platform by the customer's configuring parameters. Before that, we built the automated test template. Which greatly improves the overall efficiency of test. According to the test script management, we use the configuration parameter as a variant dependence. The platform test script can be configured to different project script. Usually, the process is that develop the test case first, then develop the test script. Develop the test script according to the test case for increasing the test efficiency. The developing test case phase is omitted, and it can be generated by the test script. We developed the test script directly against the requirements. Also, the requirements ID and variant configuration parameters are the factors. The requirements and the test case have the same configuring parameters from customer requirements. So sub-projects can be easily derived through configuration parameter, which all level test case and all level requirements. At the same time, we need to unify the change. We cooperate with Vector Shanghai using VStudio KOE to control the ETAS. Actually, it's very easy. We developed app. We just run the app. It generates the interface file. We import the interface file to KOE. Then it can control the ETAS. The final is a conclusion and outlook. Today, I wanted to focus the automating VStudio syntax validation manifold for save time, because our platform test environment has lots of parameter. When we change a parameter, the studio always stop for a while. It destroyed my test mode. So I hope it can be changed.